Hello everybody, Chaz Large here with another Fix It video, and on the bench, yes, it's another good old CUB monitor. This one was sent to me following other repairs that I'd done, and the chap who asked me to have a go at this one said there's a couple of faults on it. Picture flickering was one that was quite prevalent. When I first turned it on, the picture was jumping up and down quite a lot. It has since been calming down a little bit. So basically it needs a recap. I think the customer bought it second hand, needs a recap, but there's also this bouncing flickering picture, which he suspected might be the scan coils or something else, but my experience, that's generally down to components. So we're going to get into it and just give it a complete recapping of all the normal capacitors. Now, it's an odd one, this one. It's a slightly different one to what I've come across before, and I'll just show you the back. Whether this is a specific one that was designed as a different model. It's a 1455A MA2. It's not one I've come across. Previously it was an education. It's got two inputs, TTL and analog, with a label marked ARC and ARC down here for the switch. That's presumably Archimedes, and three controls, two for brightness and one for contrast, and that one has even got, that looks like a volume control, but there's no speakers in here that I can see, unless there's a hidden speaker in here somewhere. Or it may be a feedback, but let me just switch that control over to ARC, and all it does is make the picture disappear. Nothing comes back. I did try a couple of sort of gains things. There you go, you can see the pictures flickering up and down. That's more to do with the capacitor, I'm sure, in the frame circuit is failing. So let's get into it. The usual way of getting into these, two screws on the top and on the back. We can turn it off now. And on the back we've got 1, 2, 3, 4, 5, 6, 7 screws holding the back on, so then we can take the top cover off. So let me get that done. Right, well, I've got the back unscrewed, and yes, lo and behold, there is a speaker inside, so there's obviously an audio circuit in here as well. But one of the things that we can see straight away on these controls at the back, there's quite an element of like a crusty, almost like a mould. Not too sure what it is, but we'll treat that with the safety concerns that we have to, and clean it off. All the capacitors in there, they all look like the originals. They've got a fair amount of dust. Let's just make sure we're powered off at the socket. Yeah, I don't think any of them have been changed, and it's got quite an extensive circuit board on there for the two different inputs. So that's going to be a bit interesting, getting at all of that. Get that top panel off. Normally it comes up and comes off like that. Is it plugged in? Yes, it is. The speaker is plugged in on this circuit board here on the right. There it is. So that's useful. Now, I didn't hear any buzzing from that speaker, so I was totally unaware of it being there. But yeah, there's if we look down inside here, we can also see that on this control here there's some blue mould on there. Yeah, I think it's got all original components in it. It doesn't look like any of them have been changed, but I won't know that until I got the circuit board out of there into a position where I can actually work on it. So my simplest way of working on this is to take the main circuit board out as a whole thing, and then look at it that way. So I'm going to disconnect these connections. We've got this one here which goes, that's the video inputs, and then we've got these which are the connections to this circuit board. That circuit board has got one wire there, presumably for power, and that seems to be it, apart from that one that goes across the, yeah, they're just cable tied there together. So we can undo this cable tie because we want to get this. Do we want to take that out? Yeah, we do, because we want to get the circuit board out. So let's get this cable tie out of there. Okay, and then let's get this socket off of there. That's where the brightness controls go. That's where the switching controls go. Let's take this one off here. I think probably the easiest way, save trying to take these clips off. We've got 2 screws here. We'll just take the actual mount of the board off. We'll actually take this mount off this board here. It says unclipping those clips. Old plastic does tend to fracture, so unless I can have to undo a clip, I'll just take the mount board off like so. The power cable for this board is slotted underneath that. And some of this actually we can take, have to take this off of here. Right. So I think for ease of access, I'll take this mains connection off, and I'm going to just remove this cable tie here as well. So that should give us free access with this board out of the way. Ah, forgot the good old earthing tag, which is on here. No, need bigger pliers. There we go. And we'll just unplug it from my ISO transformer and get this board out of the way. Yeah, it's interesting. I don't remember seeing one of this board before, but this is quite an old one. This is has actually got a reference date of 1189 on it. So yeah, it seems to be, yeah, there's another date on there, 1189. So this is quite a late model of these CUB monitors. And we've got an earth on there, but before we do that, we'll just discharge the old CRT. What's the best way of discharging the CRT, I hear you ask? Well, the simplest way is to get hold of a crock-to-crock lead, what I call a Barney cable. Those of you old enough to remember the original series of Mission Impossible will know that Barney never went anywhere without loads of crock-to-crock leads. So we just pop that under there, touch on the anode cap. That discharges the capacitance of the CRT, and we should be able to just pop the little connector off. Oops. Come on. There we go. It's only 2 little prongs, and then leave the crock-to-crock lead on there, because CRTs can actually regenerate a bit of a charge if left alone. So we should now be fairly free to take this main circuit board out. Circuit board's held in by 6 little plastic clips. These do have a tendency to break, so just if you're taking these out, do take care that they don't snap off. There's an earth cable there that you should just pull off that pin. May need to use a pair of pliers to get a better grip. There it goes. Make sure you put that back. Just gently lever the board slightly over that clip. Same with this one. Yeah, that clip's just about to break. And 2 more down here. Unplug the degauss coil. Unplug the LED or the lamp at the front. Gently ease off the CRT baseboard and unplug the scan core connector, which has got a little catch on it there. Yeah, that tends to snap as well, but it does come off. And we pulled 2 of the wires out. I thought it was a little bit much, coming out a bit easier. Let's put those back in. So green nearest red. It's just, yeah, that scan core connector is wedged in there tight. Let's pop these connectors back in there. Just tighten them up slightly because that little clip has been bent back. There's one. That may actually be the root cause of the bouncing picture, if that was not making a good connection. They seem to be very loose in there. The others are nice and tight. Right, so scan cores are disconnected. Gently ease the other clip off that corner. Come on. Yeah. Now the one that always catches people out is this one that's right here at the front. There's a little clip at the front. And people don't always see it because it's hidden by part of the choke in the frame time base. Right, we should now be free of the chassis. Now, if you're taking the chassis out like this, the one thing to be careful of, especially if you're working on a set that's dead, or appears to be dead, is the fact that there could well be charge left in the main smoothing block. Which is this big capacitor here. On the main circuit board. There could be lots of volts left in there that can store up to 400 volts. So it's wise to beware of that. And the simplest way to discharge that, although it's not always a recommended way, and that's to short it out. Yeah, so it was already discharged. Right, looking at the board, there's several resoldered joints, but none of them are on the capacitors that need changing. Because this one here goes, where are we? This one here goes regularly, that's in the frame time based supply. This one here, you can see, has already started to go. It's actually the plastic has pulled away. That could be due to temperature, but it's likely that the capacitor itself is at fault. That's C28, C26 underneath, C27. So those are the ones that need changing. C311 also, and the main smoothing. I'm pretty sure that's probably going to be okay, but because it's a small style one, unlike the original old ones which were big. You can tell how big the originals were because the footprint on the PCB is for a big capacitor. Replaced with these newer ones, they didn't seem to fail so often, in my opinion. But I'm going to give it a bit of a clean up. Let's just get the earth clip off for that, then we can actually get the CRT out of the way. Off the bench. So I'm just going to get ready to start cleaning up. I need to dig out the old vacuum cleaner. Circuit board all nice and cleaned up nicely with a vacuum cleaner, and I've cleaned off the stuff that was on the pots on the side here. Basically just a little bit of like a mould, but there's no effect with the actual controls. I've checked the controls and they all seem to be okay, so it's just a case of, I'm guessing, some sort of mould that gets onto it when it's been sat around for a while doing nothing. But anyway, they're actually all working perfectly. So I've got most of the capacitors in stock. I've had to order a couple. I'm out of stock, so I'm going to get on. The old hot air guns warming up nicely, desoldering tool rather. So I should be getting on with this. So I'll come back to you after I've changed all the necessary capacitors. All been changed. Doesn't that look a lovely sight? And I've also gone over several other things that I like to do. I like to resolder the connections for the line output transformer and also the switch mode transformer. Check around potential areas of solder or overheating. We've got a couple of resistors there. They're all okay. Basically a good look over the whole board, make sure there's no dry joints. The other thing I always do on these is you'll notice on the line output transistor and the switch mode transistor there's two screws. These hold obviously the transistor in place, but also they make an electrical connection, and certainly on the switch mode transformer, this one here in particular. Let's just have a look down that one there. You can see. Alright, so we've got a bolt that goes through onto the circuit board there, and the same on these two are the line output transformer. They tend to work loose, so consequently you could end up with intermittent operation. So always get hold of a pair of pliers, grip the nut and give the screw a good nice tight turn to make sure these are nice and tight before you put it back together. So I'm pretty sure that's all okay, so I'm going to now reassemble the whole thing and give it a go, see how we go. And by the way, there's the whole bunch of all the capacitors that I've changed, and also changed the little 5-volt regulator. That sometimes goes, not always, but it's, you know, if you put a new one in, it's unlikely to fail, isn't it? Because it's being brand new. Right, let's get it all back together. Take 6.
Flippin' heck!
So here we are with the CUB, and we have fully put it back together now, and it's been on soak test for 12 hours. I set it up and I've got it connected to my BBC micro because I wanted to see why I was getting those funny things with the circles when I did the test using the electron, and sure enough it was in fact the electron is just not built to run those Watford diagnostics like the micro is. Anyway, you can see for a start off, I know it's flickering, and that's just the strobing of the camera with the screen. But we've actually got on the BBC micro test screen, we can see we've got a blue cyan background, and we've got the text in different colors. So if I put onto it, say for instance the monitor test, if I go into 6, which is the monitor test, and there I can draw the circles, which is F, and we'll see that the circles will be absolutely completed correctly with no little speckly lines. And that's obviously down to that probably the RAM in the electron, or just the interface. I don't know, it just didn't work. I've tried it again since I put it back together and it's still the same, but with the BBC it's absolutely fine. And also remember when we ran the color bars test earlier on the electron, we didn't get any colors, but if we do the color bars on here, which is I, we now get a full set of color bars, and the camera's hunting focus wise until it gets it. There we are. So you can see the monitor is absolutely working perfectly. If we do the horizontal colors, horizontal bars, that's G. That's really quite a good test because it fills the whole screen with these lines, with some text in the middle which says color should be individual, etc. So it's working absolutely fine. I'm really happy with it. The only thing I haven't been able to test is the analog input because I haven't got a source for it. Thanks very much for watching. Hope you've enjoyed this little video.